Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in today's lecture we will dive into a classic and important topic in calculus, solving first order and first degree differential equations, especially using the method of reducing to homogeneous form. And today's lesson is based on solving differential equations that are not directly homogeneous but can be reduced to that form using substitution. We will understand the method, go through examples, and learn where it might fail and what to do instead. So, consider the differential equation of the form, this form. To reduce it to homogeneous form, we use the substitution. That means x would be reduced to a constant we will add, and y in y we will add another constant k. The constant h and k are chosen so that the equation becomes homogeneous in x and y. So our goal is to make equation homogeneous in x and y. So we will substitute into the equation to get dy over dx. So instead of x, x plus h, instead of y, y plus k. So we will get this equation, and when we simplify, so we will get this one. So what we need to do, if this portion becomes 0, these two portions, so we will get equation in homogeneous form. So these two equation would be 0, and here then there would be two equation, may not always have a unique solution. So for unique solution to exist, the determinant of the system must be non-zero. That means a upon a prime should not be equal to b upon b prime. Then there would be unique solution, or you can say that the same way like this one. So you can see the condition, and let us see example. So an example we are going to solve, thereafter we will understand clearly. So differential equation is given, you can say that in first order and first degree, so that is a linear differential equation. Now if we compare with general form, we will get the values of constants like this, and this is not homogeneous, so we make the substitution. X is equal to capital X plus H, Y capital Y plus K. And to remove constant term, we will solve these two equations for H and K. And after solving, we will have H is equal to minus 2 and K is equal to minus 3. And we will have new variables. You can see that thereafter we will plug into the value in differential equation. So we will get this one. Now we are going to use y is equal to v into x, and we will plug here. So what we will have, dy over dx is equal to v plus x dv over dx, and this will imply this expression. So what we will do, we will separate v terms into one side and x term into x side. So we have to rearrange, and after rearranging we will find, we will get this one. So dv over dx, this expression we will have. Thereafter If we integrate using separable variable v in left side and x in right side, so when we integrate we will get like this one, and thereafter we will have left hand side, this would be equal to 1 upon 2 1 log n 1 minus 5v minus v square and 10 inverse 2v plus 5. This is basically based on formula, and we have to plug the values because v is equal to capital Y upon x, and thereafter we will also plug capital Y is equal to small y plus 3 and x is equal to small x plus 2. Thereafter we will get the final solution. So substitution after substitution. So if we plug, so we will get this one. So this is the final answer. Now let us see another equation. So we can write the equation, basically this equation we have, and thereafter we can rewrite in this form. Thereafter if we see a is equal to 2, b is equal to 3, and a is upon a prime is equal to b upon prime, b upon b prime. So we will plug v is equal to 2x plus 3y. So if we plug, so we will get this differential equation. Now again rearrange so that v terms would be in the left side and x term into the right side. Thereafter you will get this one. Thereafter just integrate both sides. So we will have 2v 5 log v, because 5 upon v plus 5, the integration of this term would be log v plus 5, and here 1 we have, so integration would be x, and one constant term. So finally we will have the solution, this one. So you can see that we can solve first order and first degree solution after reducing it to homogeneous form, or using some tricks, you can say that. So hope you understood. For more resources you can visit website www.postnetwork.co, YouTube channel, Facebook page, LinkedIn page, and you can also visit GitHub repositories. So hope you understood. Thanks for watching the video.